Hi, welcome back to Imperium Learning. In this video I'm just going to show you how to estimate and interpret a GJR-GARCH 1.1 model. And so as you can see, the GJR comes from the surnames of the authors who first published the model. And just a quick reminder that a GJR-GARCH model is an asymmetric GARCH model, which allows for the variance to react differently depending on the size or the sign or the size of the shock that it receives. So just very quickly, what's the difference between, say, a GJR-GARCH model and just an ordinary standard GARCH model? Well, the conditional mean equation is exactly the same as the normal GARCH model. The key difference lies in the conditional variance equation, and in particular it's this term right here that we're gonna be looking for in the in our estimation output when we do it on Eviews. So as you can see here, this I t minus 1 term, it equals 1. It's basically a dummy variable. It equals 1 if the residual of the model is less than 0 in the previous time period and 0 otherwise. And this Greek letter here, that's a small letter gamma. So when we do this test, we are going to be looking out for whether gamma is positive and statistically significant, because that would be evidence of the leverage effect. Leverage effect being that a large decrease in the price of a financial asset will cause the returns of the asset to be more volatile in the immediate future periods than a large price increase of an identical magnitude. So that's what we'll be looking out for. And just bear in mind again, don't forget about your non-negativity restraints, your constant alpha 1, which is your arch term, beta, which is your GARCH term. These all have to be positive. Gamma in this case can actually be below 0, which again, if it was below 0, that would show that the leverage effect is not present. But alpha 1 added to gamma has to be above 0. Okay, so let's just go on Eviews very quickly. I think I've already done it actually, but I'm just going to delete it, just show you how you actually do it. You click on quick, you click on estimate equation, you go to the drop down menu, click on arch, and this is the first thing that I want to draw your attention to. So this is the standard setup for a GARCH 1.1 model, but we want the GJR-GARCH model. So how do we put that in on Eviews? Well, it's quite simple. All we have to do is go into the threshold order box, delete 0 and type in the number 1. That's all we have to do. Again, our conditional mean equation is the same as before. So all we're doing is we're typing in returns AR1, AR2, AR3, AR4, MA1, MA2. That's our ARMA 4.2 specification. And then again, the optimization method should be Eviews legacy. And so at this point, we just click OK. Now again, I've got my estimation output on a PowerPoint slide, so I'm just going to move over to there so that you can do this. So as we can see, first and foremost, so bear in mind you've got for your conditional variance equation, you've got the constant, you've got your arch term in the second row, which is the resid minus 1 to the power 2, and then we have our GJR-GARCH term, which is this third row here, the resid minus 1 to the power 2 times by the resid minus 1 when it's less than 0, and then finally you got your GARCH term there. So what do we talk about? Well, you can talk about the fact that the coefficient is positive for it. So in other words, gamma is 0.0385. So it is positive. So that's a good sign if we think that there's evidence of the leverage effect. But as you can see, the p-value is 0.0676. So it's actually above, because its p-value is above 0.05, it's not actually statistically significant at the 5% level, this presence of the leverage effect in the returns of our asset. So I suppose you could make a weak argument, but you have to make sure that you use the word or the phrase weak argument, just so that you're aware, because obviously it's still significant at the 10% level because its p-value is below 0.1, but it's not statistically significant at the 5% level. So based on that, it seems like trying to estimate an asymmetric GARCH model isn't really necessary for this particular asset that I've been analysing. But at the same time, and that's another thing. Again, after you've estimated your model, make sure you do your residual tests. So we can just very quickly go down to here, click on View, click on Corellogram, click on OK. And as you can see, apart from the 7th lag, the very first one, the p-values are all way above 0.05, so we don't have to worry about autocorrelation in our model. And also the ArchLM test, how many again, you have to optimize, you have to use the optimal lag length when you're doing the arch test using a minimized information criterion. Let me just check my Excel file. Yeah, so for my Excel file, the value is up to 8. You can see that the minimized value is with 1 lag. So going back to this, the p-value, and remember you're looking at the second row, p-value is 0.96, so we don't have to worry about the residuals of our model exhibiting arch behavior. And so yeah, that's pretty much it. These are the kinds of things that you should be talking about. Even though this particular model doesn't show evidence of the leverage effect, we can still go ahead and estimate other asymmetric GARCH models just to ensure that the leverage effect is not present. So another example which I'm about to do is the eGARCH model, the eGARCH-11 model, which is another model that we can use to try and detect if the leverage effect is present. So I've shown you everything, what you need to do in a practical sense of how to estimate and interpret this model. So I'm just about to record a video on how to do the eGARCH model, so I think I'll wrap up here. Okay, bye now.